When we invoke the start method of our thread object that we created on our main thread of execution, this results in creation of the new thread, so the context switches to that new thread, it starts to run, and that new thread invokes the run method of our anonymous class. And inside my implementation of the run method, I simply call this method named time loop. So basically, the result of this is creation of the new thread and then a call on this thread into this method named time loop. And so inside the time loop, I also call current thread getName. And you've noticed that if I run this again, this is where the hours, minutes, and seconds, this string of characters is printed. It's printed by this line of code right here. Okay, and so this time loop is basically an endless loop as long as keep running boolean flag is true. And at the very beginning of it, we just obtain a timestamp of the current time by calling new date. And you know that the default constructor of the date class populates the date object with the current time. And the date format generates the desired string of hours, minutes, and seconds. And this is what we print in this loop from our background thread. So this line right here is printing all of these outputs that we generate. Right, so these outputs that we generate are printed by this line of code. And I say it here every 2 seconds because the background thread is also put to sleep for 2 seconds. It takes the same timeout, 2 seconds, to wait to print the next timestamp on the screen. And we do this 5 times because these two of these threads, the main thread and the background thread that executes this time loop, are running in parallel. Both go to sleep for a couple of seconds, and the background thread keeps printing the timestamps, and the main thread is just waiting for the countdown to become 0, and in the end prints that the main thread terminates. So when we create a new thread object, I'm using this anonymous class that implements Runnable. But because Runnable is a functional interface, we can also switch to using Lambda expressions. For example, let's make a copy of this statement. Okay, and so this example is using anonymous class, something like that. So we could start using a Lambda expression by creating a runnable object like this, and using the Lambda expression syntax. Doesn't take any parameters, and we'll use a statement block like this for the syntax. And here we're just simply calling a time loop. Okay, so this is a Lambda expression which makes a call into time loop. And here we just simply pass the runnable. Instead of anonymous class, we can just pass runnable as a parameter here. Okay, so this is in the process of switching to using Lambda expressions. So remember that every Lambda expression can be rewritten as an anonymous class implementation, but we can further simplify this by doing something like that. Just basically comment this one out, and instead just, in fact, let me put this inside the comment one more time. So I'll do it this way. I will just simply use the expression syntax inside parentheses for this constructor, and this will be just constructing the thread using the Lambda expression, which creates an object representing Lambda expression, which simply makes a call into time loop. So Lambda expressions are gaining much more popularity than anonymous classes because they oftentimes appear shorter in terms of syntax. So let's save this and run it again. Make make sure that everything works correctly. So this is our first example of creating a background thread and printing timestamps every 2 seconds.